Good morning, everyone. In previous lesson, you have learned about how to find the earthquake epicenter using triangulation method and distance time graph, the characteristics and locations of active volcanoes, mountain ranges, and earthquake zones. In this lesson, you will identify, find, and describe the different types of plate boundaries.
Alright, hello, I'm Mr. Hall. I'm going to show you the moves for the tectonic plates rap and dance. And then after that, you're going to see my homeroom kids do the dance, followed by a large group doing the dance. So pay attention to the video, and we'll list the words. So here are the moves. Tectonic plates are on the move with mountains, volcanoes, and earthquakes too. Diverge, converge, transform, 2, 3, 4. Do the earthquake shake. Transform, 2, 3, 4. Do the earthquake shake. And the second part is inner core, outer core, mantle under us. Heat from the mantle moves the plates in the crust. Then you repeat, diverge, converge, and transform. And that's the whole thing. It's about 45 seconds. Enjoy. 1, 2, ready, go.
Tectonic plates, they're on the move with mountain volcanoes and earthquakes to diverge, converge,
Transform. Do the earthquake shake. Transform. Do the earthquake shake. Inner core, outer core, mantle under us. Heat from the mantle moves the plates in the crust.
diverge,
Converge. Transform. 2, 3, 4. Do the earthquake shake. Transform. Do the earthquake shake. Tectonic plates rap and dance. Brumfield Elementary, take 1. 1, 2, ready, go. Tectonic. Inner core.
heat from the mantle moves the plates in the crust, diverge, converge, transform. Do the earthquake shake, transform. Do the earthquake shake.
All right, good job. 1, 2, ready, go. Tech.
Before we proceed to our discussion, let's watch this video. We can easily understand the movements of the different plates boundaries. Let's watch these videos.
Welcome to Moo Math and Science and different types of convergent boundaries. Convergent boundaries occur when tectonic plates move towards each other and strike one another. If you look at this map of the major plates, you can notice several that are convergent boundaries. As these plates move and strike one another, you may get earthquakes, volcanoes, or deep trenches. There are 3 major types of convergent boundaries: Oceanic and Continental lithosphere, Oceanic and Oceanic lithosphere, and Continental and Continental lithosphere. Oceanic and continental convergent boundaries occur when oceanic crust subducts underneath the continental crust. The oceanic lithosphere has a greater density than the continental lithosphere, and as it collides with the continental crust, it subducts underneath the continental lithosphere. As it sinks, magma is formed and begins to rise to the surface and may form volcanic mountains. Earthquakes may also occur and deep trenches may be formed. An example is when the oceanic Nazca plate subducts underneath the continental South America plate. At this location, the Atacama Trench has been formed in the ocean, and the volcanic mountain Lascar is located on the land. When oceanic lithosphere collides with oceanic lithosphere, a similar event occurs. The older oceanic crust is more dense than the younger crust and subducts underneath. As it subducts, magma begins to rise to the surface, and this can create volcanic island arcs. An example is the portion of the North American plate covered with ocean subducts underneath the Pacific Oceanic plate. The Aleutian Islands have been created from this collision. When continental strikes continental lithosphere, neither crust subducts, nor is magma or earthquakes occur. These 2 graham crackers illustrate what happens. The 2 plates buckle and create folded mountains. An example is the Indian plate colliding with the Eurasian plate and creating the Himalayan mountain range. I hope that helps with different types of convergent boundaries. Thanks for watching, and Moo Moo Math uploads a new math and science video every day. Please subscribe and share. Welcome to Moo Moo Math and Science and Divergent Plate Boundaries. Divergent plate boundaries occur where huge tectonic plates move away from one another. This occurs above rising convection currents. The rising magma pushes up on the bottom of the lithosphere and flows laterally beneath it. This lateral flow causes the plates to move in the direction of the flow. At the plate boundary, the 2 plates move in opposite directions. Divergent boundaries are constructive boundaries because new crust is formed. As the plates move apart, molten magma fills in the gap and creates new crust. If you look at the map of the major tectonic plates, you can see several divergent plate boundaries. There are 2 major types of divergent boundaries: continental and continental lithosphere, and oceanic lithosphere. Oceanic and oceanic divergent boundaries occur where 2 oceanic plates move away from one another. This is where seafloor spreading takes place. The most common example is the mid-ocean ridge, which stretches around the world. The mid-ocean ridge can be seen here in red. Divergent boundaries are constructive boundaries because the rising magma creates new oceanic crust and lithosphere. The mid-ocean ridge runs right through Iceland. Here's what it looks like on land. Imagine this same formation underwater. Continental and continental divergent boundaries occur when 2 plates of continental lithosphere move away from one another. As the magma rises, new lithosphere is created. The East African Rift Valley was created when continental and continental divergent boundaries moved away from each other. The Red Sea is another example. The Red Sea was formed by the divergence between the African plate and the Arabian plate. The rift transitioned eventually from a continental and continental to a continental and oceanic plate boundary. I hope that helps with divergent boundaries. Thanks for watching, and Moo Moo Math uploads a new math and science video every day. Please subscribe and share.
Our final type of plate boundary is a transform plate boundary. Transform plate boundaries can be interactions between 2 continental plates or two oceanic plates. So continental, continental transform, or oceanic, oceanic transform. The way that the plates are moving in this type of boundary is that the plates slide past each other. The plates do not collide, the plates do not diverge. Instead, they kind of slide next to each other in opposite directions. You can see that right here where this arrow is moving to the northwest, and this arrow is moving towards the southeast. So these plates are not colliding, not diverging, they're just sliding past each other. The sliding is not smooth, right? As those plates like move next to each other, they lock, build up tension, and then when that tension becomes too great, those plates snap and release energy. And that releasing of energy is what we experience as an earthquake. Okay? So, yes, there are earthquakes at transform plate boundaries. If you take a look here at the like block diagram cross section, there is no magma. So there are no volcanoes at transform plate boundaries. Okay. There is also no mountain building at a transform plate boundary. Transform plate boundaries, we might see things like rolling hills, but we're not really getting that topography like mountain building that we do at some of the other plate boundaries. So a couple of examples. One that we all know is the San Andreas Fault. And so we're seeing that here in Southern California. On the surface, this is what the San Andreas Fault looks like, right? So we're not seeing a big mountain range or anything like that. No volcanism, but we do see some topography, so some more rolling hills. The second place where we often see transform plate boundaries are coupled with divergent boundaries. So think about that mid-Atlantic ridge or where we have seafloor spreading. What also happens at those divergent boundaries are little transform plate boundaries. That's what you're seeing here, right? This ridge used to line up with this ridge, and then the plates slid next to each other, okay? Here is a really great picture, and you'll get to see this next week as well. This whole feature right here is that mid-Atlantic ridge or that divergent plate boundary, right? We have North America over here, Europe over here. And what you can see is this plate boundary is not smooth, right? All of these little offsets that you're seeing here are those transform plate boundaries.
Based on the videos and our discussions, for learning task 1, you are going to study the world map and answer the following questions. What type of plate boundaries exist in the following plate? Letter A, Eurasian and Philippine plates. Letter B, Antarctic and South American plates. Letter C, Antarctic and Australian plates. Letter D, South American and African plates. Letter E, North American and Eurasian plates. Letter F, South American and Antarctic plates. For learning task 2, you are going to complete the table. In the first column, we have the type of plate boundaries. One is the convergent, 2 divergent, and transform. Under the convergent, we have the continental, oceanic, and oceanic continental. In the second column, you are going to draw how does it looks like. And in the third column, you are going to describe each type of plate boundaries in 3 words. For learning task 3, you are going to choose the letter of the correct answers of the following questions. And lastly, you are going to write your reflection about our lesson.